All right, we're going to introduce a concept today called driving forces. So we know that some reactions occur and some reactions don't occur. Some elements are super reactive and some elements are not super reactive. For example, you can wear gold as jewelry or silver as jewelry, but don't try to wear any jewelry made from some other metals like magnesium. It would burn your skin, eventually start to react, or calcium. So we're going to go over the things that tell us that a reaction occurs. So basically a reaction occurs so that the atoms can have a more stable arrangement and lower energy. So the concept involved here is called entropy. Has anybody ever heard the term entropy? You might have heard it in physics. They refer to it more as chaos theory. Entropy is a measure of the disorder in the universe. So the universe always tends towards more disorder. And you know this. Let's say you never clean your room. You know it just keeps getting messier and messier, doesn't it? Even when it seems like it couldn't get any messier, well, it gets messier. It never gets cleaner, does it? Same thing with the kitchen. If you don't clean the kitchen, if your mom's like me, my son's supposed to do the dishes. If he doesn't do the dishes, I don't do the dishes, and they just keep stacking up. And it just keeps getting messier and messier. So the same thing happens in the universe. We tend towards more disorder. So GRUES is an acronym for our list of driving forces that we're going to worry about in this class. The first one is G for gas. That stands for production of a gas. It means that more moles of gas are produced than you begin with. So some of them are easy. So all you're doing is looking for gas on the product side for some of them. So let's think about the reaction that I did in the dancing gummy bear. Remember that? I decomposed potassium chlorate and I produced potassium chloride and oxygen gas. So we have to balance it. And you see that in the reactant side, I have 0 moles of gas. In the product side, I have 3 moles of gas. That means that production of a gas is one of the driving forces for this reaction. Some of them are a little bit more difficult. This is ethane. It is a hydrocarbon. When I burn it in oxygen gas, I always get the same products. What are my products going to be of this combustion reaction? CO2 and H2O. Very good. Gold star for the day. CO2 and H2O. So let me balance this. Let's see. If I put a 3 in front of water, I can see that's going to give me an odd number of waters. So I'm going to put a 6 and a 2, then a 4, and that gives me 8, 14 oxygen, so it'll be 7 over here. So let's count. I have 2 plus 7 moles of gas over here. So 9 moles of gas on the reactant side, and 4 plus 6, 10 moles of gas on the product side. So this would be formation of a gas as a driving force. So you can see how some would be easy, some are a little bit trickier, right? Redox. There'll be a whole nother lesson about redox, but this is a change in oxidation state. So anytime you have a change in the charge, that's a change in oxidation state. We have gone over the charges that ions form for a long time. So Oxidation state is a charge that an element takes when it's an ion. Alkali metals, metals in the first column, are always +1. That's their oxidation state. Alkali earth metals in family 2 with 2 valence electrons form a +2. That's their oxidation state. The oxygen family has 6 valence electrons. It'll gain 2 more to have an oxidation state of -2. Halogens are always -1. So you've learned something about the oxidation states. We just need to remember this and apply it to here. You can remember oil rig. Oxidize is loss of electrons. Reducing is gain of electrons. I like Leo the lion better, because then I get to use pictures of lions instead of oil rigs. So Leo the lion goes grr is our mnemonic trick for this. So that means if I lose electrons, I'm oxidized. If I gain electrons, I am reduced. The easiest one to pick out is water. All you have to do is look for HOH or H2O in the products. Has to be in the products, doesn't matter what state of matter it's in. Could be solid, liquid, or gas. But as long as H2O or HOH is in the products, formation of water is one of the driving forces. This last one, S, stands for solid. This isn't just any solid, so this can be a little tricky too. It has to be a solid that is formed from 2 aqueous solutions. So you need to have a double displacement reaction, and the 2 reactants have to be aqueous. And then one of the products has to be solid. Typically the other one is aqueous. So I want you to remember me putting together the silver nitrate clear colorless solution. Remember, it was in my graduated cylinder up here, and I added sodium chloride clear colorless solution, and seemingly out of nowhere we got a solid white precipitate that settled to the bottom. That's formation of a solid. It's not just any solid that's in the product, so be careful of that. Okay, this last part we're going to kind of classify what are the possibilities for each of my types of reactions. So synthesis, we can have formation of a gas. Most of the time we'll have redox, and we can also have formation of water. Same thing with decomposition. Combustion can also have all 3 of them, and so can single displacement. Double displacement is special. So it's going to be a little bit different. It can be formation of a solid and water. So these guys here can never be formation of a solid. That's only a special double displacement reaction. And our double displacement can never be redox. There's also a couple clarifications. Combustion and single displacement are always redox. Synthesis and decomposition usually are, but not always. So there's a couple clarifications. And hopefully this will keep you from throwing around that formation of a solid driving force. We're now going to clarify double displacement. So we already went over our precipitation reaction. In order to be a precipitation, it has to be formation of a solid. So you've got to be forming a solid in order for it to be precipitation. That's when we have two aqueous solutions and we form a solid in the products. The other product is usually aqueous, not always. The other type that seems to be confusing, and I've gotten the most questions on this, and I kept trying to tell you we will clarify, and we will clarify a little more, is let's go over acid-base neutralization. This one always has to be formation of water. So my double displacement reactions are going to have one driving force. It's either going to be formation of water or formation of a solid. That formation of a gas is not something that we're typically going to run into in this class, but there are reactions that do that. So the general form for this is we know something's an acid when it starts with H. That's just the general form of an acid. You're going to see this all over the place. If you see HX, it doesn't mean a specific acid. It just means any acid. Could be HCl, hydrochloric acid. Could be HBr, hydrobromic acid. Could be HNO3, nitric acid. Could be H2SO4, sulfuric acid. That's just the general form for an acid. And then the general form for a base is like such. It'll have a metal and a hydroxide. There are some other bases, but you won't learn that this year. That will be a next year chemistry topic. So a hydroxide or an OH group at the end makes something a base. What's going to happen is double displacement switch partners. H can't go with M because they're both cations. So you never put two cations together, never put two anions together. So if H is not going to be with X, it has to be with OH. And if M is not going to be with OH, it has to be with the other anion. So on the other side, you're going to get a metal salt, it's called. A salt is a general term usually for the product of a neutralization reaction where you take an acid with acidic properties and a base with basic properties and put it together and get a neutral or close to neutral salt. And the other product is always going to be water, which will be listed as H2O or HOH. Let's do a couple practice problems together. Our most common problem is when we take hydrochloric acid, which is a strong acid, and we add it to sodium hydroxide, which is a strong base. They will switch partners, and H won't be with Cl anymore. It's going to be with OH to form HOH. Remember, HOH and H2O are the same thing. And then the other two are going to be together, and that's NaCl. It's called neutralization because if you add the same amount of acid to base together, you will get a neutral pH 7 solution. Let's do another example. Nitric acid is added to magnesium hydroxide to give me, of course, H2O. So when you're predicting products for acid-base neutralizations, one of them is always going to be water. And that takes care of the H here and the OH here. So you can say to yourself, the other salt has to be the other two together. You don't just say MgNO3. We have to remember that NO3 has a charge of -1 and magnesium has a charge of +2. In order to account for the fact that we have an imbalance here, we will have to balance the equation like such. One more. H2SO4 is sulfuric acid. And I'm going to add it to potassium hydroxide. They will switch partners. One of them is always water. And the other one is going to be the back of the acid in the front of the base. Have to make sure that we're using our rules that we learned during naming and not just coming up with compounds out of nowhere. 2 and 2, we will balance it. You'll never be able to balance it if you don't get the formulas right. That's the hard part about all of this. So that's a little summary of acid-base neutralization reactions, if that was confusing to you. So those are the driving forces for our reactions. And we're going to spend the rest of the class period practicing those.